Hi, this is Dan Bullard, retired electronics engineer, sitting on the fret deck of my houseboat again. It's New Year's Eve. Lots of busy stuff going on down here, so don't worry if somebody comes by or makes a lot of noise. I want to wrap things up this year with a little bit of talk about my latest discovery. It's huge. Nobody knows Law 5. Law 5 says that if you distort a sine wave, that the phases of the individual harmonics will always be at 0, 90, 180, or 270 relative to the fundamental. Now that's not just by observation. I'm not like Tony, who comes up with observations. That's not just observations. It's an observation, and then I went and found out why. Because distortions happen at a point in the transfer function, they're hit on the way up and on the way down, or on the way down and on the way up. So they're going to be symmetrical around 90 degrees or 270 degrees. Now, they may not be symmetrical if there's hysteresis. And so any hysteresis will cause a difference. And so if there is a difference between the phases of the harmonics and 0, 90, 180, and 270, that difference can be construed as hysteresis. I'm always trying to measure things. I've been in test a long time, and whenever you're trying to test something, you may find it a crazy way of doing it. I did that video way back when, way down there, down at Fort William Bend, on measuring pulse width. Tony's got this crazy idea about measuring pulse width, that you can calculate pulse width of a square wave based on the amplitude of the second harmonic relative to the fundamental. That is complete horseshit. And I told you this before. I had a colleague at Credence who said, oh, the amplitude of the harmonics of a square wave are always 1 over the harmonic number. Well, that's only true if it's exactly 50%. And I dare you to get that answer. I don't think you can, because you have to be perfectly aligned. You have to have perfect timing. You can simulate it in Excel or in some other thing, Octave, whatever, as Dan, what's his name would say. But I was tasked with measuring pulse width by HP for Christ's sake. And so when HP says, hey, measure this and measure it accurately, you got to do your damnedest. I figured out how to do pulse width of a square wave without a TMU. That's what we would normally use. But I used the Bunneman function. Daver came up with that, Dave Reynolds. He came up with the Bunneman function, so you can look at the amplitudes of the two highest things in the spectrum, the amplitude of the fundamental and the bit next to it, to see what the skew was, how far you were off from being coherent. If you're dead nuts on coherent, that's great, but it's not always going to be the case, especially if you don't know the frequency of the thing you're measuring. So we use the Bunneman function, and the Bunneman function calculated how far off you were from being coherent, and then we could just chop off the waveform closest to coherence, and then we could measure duty cycle, which is high time versus low time, and just by looking at the number of ones versus the number of zeros by capturing the waveform. So that's what I did in my life. I found ways to measure things by looking at laws of physics that apply to a real wave. I talked to Daver about this. Daver actually called me about this last video, and he said I was being a bit arrogant. I love it. I love it. If you discover something great, you're arrogant. I admit it. But Daver said some interesting things. He could do an FFT with 500 bits of resolution for each data point. There's somebody out there, I don't know what they're doing. Oh, there they go. So 500 bits. Now, 64 bits I think is good enough. But it'd be nice to do more. You get really, really accurate results. But QSpice or Spice is using 32 bits, and that's not enough. It's not enough. You look at these numbers from QSpice, and They're horrible. They're close. I mean, someone might look at that and go, oh, well, yeah, they're close to 0, 90, 180, and 270. And by the way, what is 270? I see it all the time. When I measure my phases, 270 actually comes up as minus 90, because minus 90, its sine wave is minus 90 relative to a cosine wave. So minus 90 degrees is actually 270 degrees. So I always say 0, 90, 180, and 270, and the 270 might be in minus 90. You just have to look these numbers. The minus sign doesn't necessarily mean what you might think it means. Okay, so Daver could do like 500-bit floats with his stuff, and he could do that. I can't do that. Daver's much smarter than me. But if you want to measure something, and that was my goal in life, was to measure things that nobody else could. And so I did that for HP, and I came up with the pulse width, the duty cycle of a square wave, and it was incredible. The accuracy was like 200 picoseconds on a tester that only had an accuracy of 2 nanoseconds. So 200 picoseconds, that was pretty good. Anyway, Happy New Year. And from the river, once again, this is Dan Bullard. See ya.